Good morning, good afternoon, or good evening, depending on where you're joining us from today, and welcome to this CM Crossroads webcast series event, Private Clouds for Development, Exposing and Solving the Self-Service Gap. This webcast is brought to you by CM Crossroads and is sponsored by Electric Cloud. I'm Patrick Egan, publisher of CM Crossroads and the Agile Journal. Well, in a few moments, Usman Muzaffar is going to join us to discuss how to leverage the benefits of cloud computing for build, test, and deploy tasks. But first, let me take care of a few housekeeping details. I hope you enjoy our new interactive live cast platform. We've completely redesigned the way we deliver online events of all kinds. So the first thing you'll notice is the new event chat window that's right below this screen. This is going to let you submit questions to the speakers as well as chat with other members of the audience. One thing I might want to mention too is that you can pop out this window from the browser by using the pop-up button that's way down at the bottom of this screen. This will let you undock it from the browser window so it won't get covered up by the slides. Also, if you need to get a closer look at any slide, just mouse over this screen and you'll see a full screen icon pop up. That'll expand the window to the full size of your browser window. Also, if you'd like to follow along with Facebook or Twitter, use the Facebook or Twitter icons at the bottom of this screen. This will let you tell everyone else about this presentation and tell them what you think about it. Also, if you'd like a copy of today's presentation, you can use the slides link over on the side of the screen there. This lets you download a copy of the PowerPoint presentation as well. Also, a copy of this entire live broadcast, including the Q&A session, will be available for on-demand replay shortly. Well, first, let me introduce our speaker today. Usman Muzaffar is the Vice President of Product Management for Electric Cloud. Well, Usman, if you're ready to go, I think people would rather hear you than me speak, so the floor is yours.
Well, and one more thing I wanted to mention, Usman, before you take over is if people are going to tweet, please use the hashtag CMCLC, and so that you can let everyone know, and you can see your tweet appear in the live event chat roll over to the right there. Well, again, if you're ready to go, Usman, I think people are ready to hear you, so the floor is yours.
Thank you very much, and hello, everyone. My name is Usman Muzaffar, and I work for Electric Cloud, and today I'd like to talk about private development clouds, especially using private development clouds and what is the exposing and solving the self-service gap. So really, my talk has just three parts I'd like to talk about today. First is what is a private development cloud? Why would you want one? And then what is the problem with it? Why is there a gap? The self-service gap is the name we've given to this issue that prevents most organizations from having one and using one effectively. And then finally, of course, to talk a little bit about what Electric Cloud brings to this problem and what our solution is. So first, let's just, a second on cloud computing. It's pretty clear to everyone that cloud computing is here. And really, there's three sort of undisputed benefits of a cloud architecture. The first one is that you can access stuff anywhere. We're no longer living in a world where the bits are trapped on my laptop or they're stuck on a server that I won't necessarily have access to. They're going to be in the sky, and any client which has access should be able to get to it. The second real advantage of almost every cloud-based system or cloud technology that you see is virtually unlimited scale. The idea is that as you need more resources, the cloud will expand. There's this elasticity aspect to it. It will grow to meet whatever needs you have. And the third thing that is very appealing about anything that tends to have the word cloud in it is the idea that as the end user, you're only going to get billed per use. You don't have to start reserving giant blocks of capacity. You're going to be only charged for the part of it that matters to you. And the public cloud potential is that if we can give our users all this without the data center, without having the rack of servers, well, then that would be phenomenal, right? If we're able to deliver all these benefits, access anywhere, unlimited scale, and pay-per-use without having people to actually manage and maintain their own servers, that would be a real win. There's a serious problem with that, though. I call it the Spies and straws problem. The first one is that if it's going to be my IP, it should live on my hard drive. Whether that hard drive is in my data center or a data center where I have direct control, but it shouldn't be the case that somebody with a screwdriver can, walk up to a server and have access to my intellectual property. And the second problem, this is a technical one, is how are we going to get the bits up there? If it's not gigabit within most organizations, you may as well forget it. It's not fast enough to transfer the volume of data we have. And it's not just cloud computing in general, but software development in particular has this problem in spades. The amount of content that is produced in a typical large organization just on any given build is just too much. It's too much for us to say, well, we're going to live with on our own systems and then we're going to push this stuff back and forth to the cloud. The I/O bandwidth just isn't there. So what does that lead us to? That leads us to the conclusion that if we want the cloud benefits, we want the inside our firewall. We want it to be on our servers with a really fat pipe to our users so we can start to get those benefits for the inside the organization. Then the next question is, who's going to use this first? And if you look across any kind of transformative technology, there's always some potential market. There's some subset of users who have the crystal clear success case, right? And so pose the question this way. Who stands the most to gain, or rather, who most needs universal access to a lot of different systems? Who most needs the ability to easily scale because their growth and their need is constantly growing? And who has the spikiest loads, whose demand is constantly shifting, and so the idea of elastic assignment is critical? And I think when you phrase the question that way, the answer is pretty clear. The answer is it's the software developer. It's your friendly hacker, because more than anyone else, they have the need to support completely heterogeneous systems, different operating systems, different platforms, different configurations, different branches, right? Second, they have a very wide variety of tools. It's not just that they want to be able to print. It's not just that they need access to a CRM database or they need access to a simple print service, for example. They've got a lot of different tools that need to connect and play together, and those tools vary from one group and one individual to the next. Well, I'm working on the back end. Well, I use Java. Well, I'm working on the embedded client. Well, I use C++, and all the associated tools there, so the workflows vary. And finally, the load is just all over the map. The night before release, we need as many systems as you could possibly muster. But, the day after we've shipped and we're just, we got our feet up on the desk and we're throwing around ideas for, version N, we don't necessarily need 500 servers. We could probably get away with just a couple of boxes, but they need to be running the latest stuff because we're prototyping new things. So when you throw these requirements on, it's clear that dev is the private cloud customer. But when we start to look at what the infrastructure is today for an organization, and we start to layer on, these are the requirements, multiple platforms, every kind of OS, different handset, different mobile operating systems, different sites geographically in the organization. Even small companies now are going to fully virtual teams where the individual developers and contributors are scattered all over the globe, multiple product lines, and now different user populations. It's not just development, it's the QA team, it's the release team, it may be the ops team, this thing is going to be a hosted service. So you have all these different axes on which pressure is coming onto the development infrastructure. And the interesting thing is that when we start to flip, turn that page over and what's behind the infrastructure, what kind of information systems and development hardware is supporting those different axes, we see that it's fragmented, right? The Sunnyvale team has its own population of servers. They've got their own setup, and they're configured in a certain way. They're plugged into the router in so one way. The Bangalore team, even though they may be working on an identical product, they've got their own angle. They've got their own net app over there that's plugged in their way. Furthermore, if I look across product teams, product A may be using one set of servers and a one kind of configuration, and product C, well, they came in through acquisition, so they're using a completely different thing. Then it gets split up by user group. And then, of course, there's a natural division along operating systems. So we have this natural fragmentation. And this is where all the problems come, because the servers organically divide themselves. They organize into the way that's most efficient for the organization. There's this well-known principle that teams and people will start to reflect the organization of their communication lines. And the interesting thing is the same thing happens with hardware. We start to see a fragmentation here around how, but it's on multiple axes. It's on geographic, it's on product, it's on user populations, and it's on operating system. And that leads to the 7 ins, uns, nons problem. From the point of view of the folks who are responsible for maintaining the global view, that fragmentation manifests as a giant heap of hardware. It's just a big mishmash. I can't authoritatively say these are the machines that are officially used for building. I can't say this is exactly what is used. There's one chart of every Linux machine in my organization. The result is that from the end user's point of view, these machines start to become invisible. I don't really know, where things get built. That's release's job. I don't really know. It's ill-defined which systems I'm supposed to be using for building our iPhone client. When it comes to scaling, then how do I know which machines I should be plugging more into? How will I share them? Sharing becomes almost completely impossible because things are inaccessible. I only have access to the few things the few machines I know about. I don't have even the facility to start talking about a standard because there isn't a framework in which I can even plug all this into. Put another way, these are all just synonyms for the real underlying problem, which is inefficiency. At the end of the day, when you start to draw the picture this way, you know that your organization has spent time, money, and resources setting up infrastructure that you're not getting the best value for because it's not being shared. You can't have a way of measuring it, and you certainly aren't getting the value that you put into it. This is the problem that we spend a lot of time thinking about at Electric Cloud. Why? Why is inefficiency such a constant problem? It's not like we don't have bright people. These are some of the smartest organizations, some of the most successful organizations who have invested in their IT infrastructure and who have invested in their development teams. Why is it that we always have this sense, and whenever we try to measure it, we can actually quite quantitatively prove that things are inefficient, that we're not scaling, that we're not sharing, that we're not making things accessible, that things are invisible. And if inefficiency, when you think about it, that really is wasted cycles. If you had to define it in 2 words, you'd say that, well, we're putting effort in, we're not getting results back. Why? I think the answer is that there are 2 different kinds of cycles here. On the one hand, there's the development cycle. And that's the classic edit, compile, debug cycle people have been talking about for 25 years. What is the development cycle? If you're trying to optimize it, what are the axes you're going to pick? You're going to think, how fast can I make it productive? How fast can I just turn that crank? And can I make sure that on every iteration I've got the highest quality? Your talented, your most goal-oriented developers are not going to be thinking, by design, are not going to be thinking about, well, how many machines does this take? How many watts of power is this consuming? They're not worried about that. They're worried about the edit, compile, debug cycle, how fast, how accurate, how productive can I be? Conversely, on the other side of the fence, folks who are paying attention to the machine cycles, the ones who did write the check to the big server and hardware and network providers, they're thinking about utilization. If I convinced my CFO to write a big 7-figure check for hardware, can I say to him that that's actually being used? Are those gigahertz idle, or are they busy working on product development? Are they being secure? Is it secure? Not just black hat security, but are we actually ensuring that we've got the right boundaries so that people can, only the machines are being allocated to the right groups, that they're not being abused by people who are just being lazy? And finally, where they are being used and they are secure, how are we going to scale? If it's n today, it's going to be 2n tomorrow and n squared day after tomorrow. How are we going to grow this? That's the other kind of cycle. That's the machine cycle. The fundamental problem is, because these are 2 different issues being looked at by 2 different populations, not surprisingly, we're getting 2 different solutions. The development team, how do you address productivity? How do you classically address, let's get the dev cycle as low as possible? It's heterogeneity. What's hammered into developers, into engineers from the beginning of their training? Right tool for the job, right? Figure out, ask your question as clear as you possibly can. Eliminate distractions, find exactly the right tool for the job. This is the Unix philosophy going all the way back to the late 60s, right? And that means heterogeneity. That means, look, we shouldn't be scared of using different tools for different things. If Java is the right tool for that, well, then let's use Java. Let's use the best Java tools, the best Java debuggers. And if that means we need to use embedded C on the front end, on the client side, well, then let's use the best tools and technologies we have there, and let's isolate our infrastructure so that we don't get distracted. In short, hey, boss, let me own it. Let me pick the technology. I'll figure it out, and we'll have developers who are just flying along with the best productivity we can possibly get. How about the IT side? I've talked to some people who have just staggeringly beautiful IT infrastructures, and the one hallmark they all have is it's beautifully homogeneous. You want to make things efficient? Let's do it one way. We're going to lock on an SKU. That is how that's the kind of server we buy here. They're all imaged off of the same hardware or virtual image. And if we're going to have more than one system, we're going to make absolutely sure that we push our vendors to have good, tight integrations. In short, hey, boss, let me own it. If you let me set up the infrastructure, we're going to get the efficient solution. What's the problem? So the problem is you've got two very bright groups of people who are working almost at odds. The developers are striving for independence, but their independence is going to lead to more fragmentation, and it still doesn't solve their problem of workflow automation, of being able to tie all those tools together when every individual group has siloed themselves. Meanwhile, the IT group is pushing towards standardization, and that makes dev efficiency worse because you have less ability to pick the right tool for the job, and it still doesn't solve the low utilization problem. I've seen organizations which have fantastic, just racks upon racks of servers, and when I ask them what they're using for, the answer is, well, actually not quite yet. We haven't really deployed this yet. The development team isn't quite using this yet, and it's always because it's not quite the quite version of libc for the Linux kernel, and so that particular compiler, the compiler the dev is using today, can't use. In a nutshell, at the end of the day, you always wind up in this awkward world where it feels like the people are too busy, but the machines are too idle. Our vision of the solution to this problem is what we call a private development cloud. We believe if you can come up with the infrastructure that can sit in between development and the infrastructure that IT provides, so that you minimize the cycle time for the individual developers for all the processes and workflows that they care about, that they're actually doing to run their job, and yet maximize the machine use from the massive infrastructure that IT is providing, then you will have won. You'll get the best of both worlds. And if you can do that and provide accessibility and elasticity and the ability to be charged only for what you use, you'll have nailed it. So what that means then is like, so what is the gap? What is the problem? If that vision sounds good, yes, that is what we want. What is it that is impeding our ability to deliver that today? And it's a good question to ask at the beginning of 2011 because after a year of hype around cloud, there are now some very interesting technologies that are maturing that are starting to give organizations the ability to build their own cloud. In particular, if we were just to draw the layers of the sort of the compute infrastructure as we enter the second decade of the 21st century here, there's a lot of powerful players at the storage layer. We've got fantastic network-based storage, which can be replicated, clustered, a lot of interesting and powerful and mature technology. There's no shortage of people who will sell you an x86 box or even other architectures now that will be able to be high-density cores, lots of machines, lots of compute power centralized. Over the last decade, we saw the rise of virtualization. VMware probably is still the most commonly seen architecture that I've seen with our clients, but definitely other virtualization technology, and now a layer on top of VMs. A classic example would be VM's Lab Manager, but Microsoft System Center, but organizations like RPath and Eclipse, if you haven't heard those names, of organizations that are providing a layer on top of the virtual machines to make it easy to provision them and to manage them. At the end of the day, these give us the ability to ask for exactly the machine we want. We had multiple layers. We have the facility to build and deliver to our end users just the resources that somebody wants. Now, how does dev going to interact with that? Well, the interesting thing is your developers may interact with that at any level. You have development operations that may want to integrate with it at bare metal. Look, I need the actual raw box because I'm going to send it commands. You have development organizations that want to work with a VM layer that's on top of that. And now as we have managed infrastructure on top of that, I'll have the need to interact with the managed VMs. So let's pause for a second and see. So with the combination of developers being able to hit these different layers and these different layers being provisioned, what do I have? Do I have machine efficiency? Yes. I can construct an IT environment where I can deliver the density on one hardware box that is going to get me the economy of scale. I can support heterogeneous platforms. I can isolate the piece of it that I'm trying to do. I can even standardize. I can say that all machines are going to come from the same template. In short, I can give my developers a world where if I push a button, I get a box. And in the most sophisticated organizations we've worked with, we've actually got this. They can log into a central lab manager infrastructure, and they can say, I want Windows XP SP2, and I want to make sure it's got Visual Studio 2008, and please give me an image of that, and they can push a button and get a box. But that's not enough. And the problem is, what's missing is that that system still doesn't know what you're going to do with that box. Even if you give me a box with Visual Studio 2008, now I'm still on the hook for having to go log into that thing and kick off my build. And log in where? I've just been handed a whole bunch of IP addresses. I'm going to start making shortcuts to those on my desktop and start logging in. Where does the data go? Where does my build output go? I don't want it sitting around on that VM stuck there. And how about the whole workflow? Step away from what I'm trying to do. I'm one member of a team of 50 guys. How are we all, what's coordinating all of our efforts? In short, yes, I can push a button and get a box, but that box is empty. It's like going to a car dealer. It's like going to the to a store and configuring. I want exactly this kind of car, and being given it and being told, well, here's your car, sir. Now you're on your own. Hope you have a good map and a GPS and drive away. You're on their own for driving. Why can't we have the system drive for us? Why can't this be fully automated and get us all the benefit we need? And that's really the gap. If we look at the classic definition of a cloud, people will always define it as, well, there's an infrastructure layer, there's a platform layer, and there's an application layer. We can fill in the platform and infrastructure layers. We've got the virtualization, the ability to virtualize infrastructure, even the ability to virtualize platform. But there's a big question mark, 3 question marks, where the application layer is. What is actually going to sit on top of that and give the service to your developers? And that is what Electric Cloud provides. We are the solution that sits on top of either your raw hardware, your bare metal, sits on top of your VMs, or sits on top of, in the most sophisticated customers, the cloud infrastructure. But in all cases, we are providing the end users, your developers, access to the services, instant access to the services that they want to be able to do their job. And that's what the Electric Cloud solution does. So I'd like to spend a few minutes talking about what it is we actually do. And I thought it would be good to sort of, let's dive in. So we talked about what the benefits are, instant accessibility, the elastic assignment, unlimited scale. But let's zero in on this. If we're going to devise a system that is going to sit in between the developer workflow and processes, the builds they need to run, the tests they need to run, the deployments they need to do into test infrastructure, all the day-to-day activity, basically everything your developers do other than thinking. You want your developers, those are knowledge workers. If they're doing anything, if they're typing even, they're wasting time, right? You want them to be thinking and have the typing be at a bare minimum, and anything else that's ancillary is just getting in the way. And if we want to map that, to sort of align that into the IT infrastructure, what are the real core problems we need to solve? It's these 5. If we're going to have a system that's going to understand, it's going to work for developers, it's got to really understand what development does. That means it's got to have first-class integrations with their tools. It's got to understand their workflow. It's got to be a kick butt at automation of being able to actually tie together the kinds of processes they need to do. And above and beyond all, if we're talking about software developers, it's got to be flexible. More so than any other discipline, software developers are in the unique position where they have the ability to craft their own tools. Carpenters don't make hammers, right? But software developers are the same people who build the compilers. This is a fundamental difference, and that's why developers are so hung up on flexibility, because at the back of their mind they know, dude, I could script this myself. I could come up with a better tool. And you want to make sure you empower them and not work at odds with it. Second, it has to be fast, right? I need to be able to do things at the maximum speed, and in this day and age, that means using parallelism. That means harnessing multiple cores and harnessing multiple machines. And that means when I ask for a box, that means I get a whole pool of resources easily so that I can scale things. It needs to be secure, and secure there's 2 sides to secure. Yes, there's encryption, and yes, there's security, and there's all making sure that you're going to be compliant with your IT organization security rules. But really, it's all about, look, I should never have the ability to accidentally remove all my source files of my neighboring team. I should never have the ability to accidentally break the nightly build. But I should also always have the ability to leverage work that others have done. So it's security without blocking sharing. It needs to be usable. It needs to have a UI that does what I want it to do, not that I'm asking, here's another enterprise tool that IT has dragged in with its own login and its own goofy UI, and I'm supposed to now use this instead. And finally, I would say the single most important thing is where is all the data going? Not just the actual outputs to build outputs, the artifacts. Yes, of course, we need a solution for that. But what's capturing what's going on in the system? Who's recording what builds are going? Who's recording where we are in the workflow? What are we actually doing with all this metadata? Do we even have a system which can capture it? Because only then can we measure things. The old adage, you can't manage what you can't measure, is still true today. And if you can capture all this metadata efficiently and seamlessly in the background, then you give the people who are making the decisions the data to make the most useful stuff. So what does the Electric Cloud solution look like? In short, we have 3 products. Really 2 product lines. Electric Accelerator is all about making the build fast. That uses the power of the private cloud to make your software build go fast. Wherever you are currently type make, or you hit F9, or you select build from your IDE's project menu, just imagine how much better it would be if the minute you did that, things were 2x, 4x, 8x, 10x, 20x faster. That's Electric Accelerator's mission in life. Use the cloud to seamlessly virtualize your build onto a cluster of machines and make things go fast. Electric Commander is about solving the wider problem. How do I map a process to a set of machines? How do I make sure that I have workflow automation? How do I integrate with all my tools? How do I make parallelism work at the larger level? And above and beyond all, how do I capture all that metadata and make reports easy? Insight is a companion tool to Accelerator to give you visibility into an accelerated build. Why is it that my company's been able to solve these problems? It's because we've spent a whole decade collecting some of the brightest engineers in Silicon Valley to attack some of the core problems that are underneath this. I'm not going to go through this whole slide bullet by bullet, but it's how do we make sure that we can do remote execution? How do we get really good at network file systems? How can we capture workflow and process? How can we make things easy for people and different roles? And that technology has fed into our 2 main product lines to attack these problems. So I just want to walk through them and show you examples of what our products do for each of these. When we talk about understanding development, what do I mean? A lot of people who are not in development, especially upper management, occasionally forget how many different moving parts there are in a software development workflow. And I love presenting this slide, next slide, to an organization just to show this is how many different classes of systems a typical organization has. It's not just a compiler and a linker. If the last time you built software was in 1985, that's your model of it. Yeah, you type sources and you type CC and you type LD and you have an executable and we're good to go. It doesn't work like that now, right? There's source control systems. There's integrated IDEs. There's a whole class of build tools, defect trackers, code review, unit test, analysis, static analysis, system tests, performance tests, and then you've got to deploy the software. And within each of these buckets, there are multiple different members, and an organization may be using, with good reason, several citizens within each class. So the volume of tools we're talking about and the disparity between them is staggering. And furthermore, where we are running these things is not just the Dell box in the corner. It's virtual environments, it's computer environments, it's the private cloud, it's the public cloud, it's everything we were talking about earlier. How are we going to map all of those tools to those compute infrastructures? And the idea is to do it with virtually no change to your tool setup. I don't want to have to rejigger things. I just want to, if I've got a script that calls my static analysis tool, that's the script I want to use. And I want that script injected into my flow. What does that look like in Electric Commander? The essence of what we're talking about is reusable automation. Here you see a procedure. A procedure is a set of steps, and a procedure you can think of as a programming function. It's got all the power of a programming function. We've got substitution and nesting and subparameters. And what I want to call your attention to is those middle 3 lines where it says build and test on Windows, build and test Linux, build and test Solaris. Notice that the definition, the action for those 3 is a common build and test template. One time, I defined a single template, and different platforms were leveraging it. That's the power of reuse. And if I were to double-click on that build and test template and show you what it looked like, inside that thing, I've got a build step, a unit test step, local system test, cluster, full system test cleanup, very generic steps that know how to change their definition. It's classic. It's easy to explain this to a technical audience. It's instantiation, right? It's polymorphism. I've got a definition that knows how to change itself based on inputs, in this case, based on platform. And Commander gives you the facility to define a framework that you specialize you override, you instantiate, you derive class so that you can give exactly the behavior you want. That's the heart and soul of reusable automation. Create process templates, a single build and test procedure that handles all the platforms and gives you customizable runtime behavior. What does this mean on the other side? That's diving in, but what about when you pull out? One of our customers is PTC, and they've got a very wide and varied product line that, like a lot of big companies, has grown by acquisition. What does it mean if the boss said, you know what, we're now going to start on a 10-month project to integrate all our different products to put them into one master line? The vision is for us to push one button and have all the products in this company build with a single build ID wherever they are. That's the kind of thing that gives people, really their heart starts to palpitate. Like, oh my God, that's going to take us forever. We're never going to get that together. There's too much disparity. But with Electric Commander, you take a different approach. If you can, since it's so easy for me to define my procedures independently, I can aggregate them. The universal build in Electric Commander is as simple as I define 3 sub-procedures. I click the parallel checkbox to mean that all of you guys are allowed to run in parallel. And now I have a single button push. When I hit that green run button, all 3 of those are going to build, maybe not even on the same continent. Maybe the Europe team is the one that's going to be building component product 2, and that's going to run on their servers across the pond, and I'm going to have a different set of servers in India building the enterprise server, and a different set here in Silicon Valley building the client. In short, we can separate, we can have different projects for our teams, for our products, but we can easily unite these with cross-project procedures, and this is the essence of what a private development cloud should be able to provide. And getting back to the idea of a private dev cloud, you can't reasonably say, guys, well, our goal is to stamp out the fragmentation unless you have a system which can realistically unite everybody. And that's exactly what Electric Commander is trying to do here. When we talk about DevTool integration, I want to be able to show a screenshot of Eclipse, which is what you see on the left, and show you I've got a first-class integration with that. And when you launch right there, I've got a plugin which will launch Commander, and you're not going to have to leave your IDE. It's going to give you access directly in where developers are. I've got developers who never even log in to the Commander UI and are still able to get all the benefits of being able to run their processes on the cloud in the scalable way, get results without ever having to muck with anything on their local side. From their point of view, it's just a plug into their IDE. How about the holy grail of being able to run things again? How many times, raise your hand, I think we even have a raise your hand icon, if you've ever been frustrated that you ran a build and it didn't work, you weren't quite sure, so you ran it again, and this time it worked. Or the reverse. I swear to God, this thing, I ran it, now it doesn't work. What's going on? I'll tell you what's going on. It's non-determinism. Something changed, and you don't have your finger on it because who knows what systems you're using? Who knows what inputs you have? Who knows exactly what timing it used? In my product, this is something we wanted to put right front and center in Commander. We put a run again button. We should always be able to tell the system, do that again. And I may be able to tweak certain inputs. Why can we pull this off? Because we captured every single possible input. I know what debug setting you used. I know what platform you used. It's not about somebody having to type arguments, three terminal lines long onto a command prompt. Commander captured all this. It knows precisely what systems it used, and it can run them again. That's, again, a clear benefit of once you've got it defined in the cloud, you can get this. But let's, again, talk about now when we want things to run in parallel, when we want to be able to get not just one box. It's time for build, it's time for test, and I need a whole cluster of systems. What happens? This, of course, I mentioned Electric Accelerator is our tool which can run things in parallel. Here's a screenshot of Accelerator running a build on a series of hosts using multiple cores on each of those hosts. And what you're seeing here, each one of those little bricks represents the compile that it has distributed, and it has dynamically discovered. Notice that big serialized step as it serializes on agent number 5. There's a chunk of work which was not safe to run in parallel. And that's the essence of parallelism, is you need to make sure that you don't accidentally break things, because race conditions become a heck of a lot trickier when you run things in parallel. And Accelerator not only identifies that, it corrects them. Here's that same build on a subsequent run, and here you can see it's really compressed that problem, and it knows what the ideal dependencies are. It optimizes the network transfers and gives you analytics like this graph, where it can even call the shot and say, this is the speed up we're getting, but as we add more nodes, all the way up to 10 more nodes, you're going to get this build down to 6 minutes. And only Accelerator can do that because it has such tight integration with what's running on the cloud and easily virtualize what's on your client machine so you aren't in the racket of having to reserve resources. But more than that, when we talk about what Commander brings to resources and parallelism, the vision is that we need a way to flexibly and securely control a large population of devices. So we want to be able to tag machines in different ways. I don't want to just say the Linux pool because maybe I want the Linux 2.2 kernel pool. But maybe I also want to be able to say all the machines that participate in the version 3.7 of my product build. I need a full-blown tagging mechanism. Hierarchies, partitioning, that's not going to cut it. I need to be able to tag things in pools in different ways. I need to be able to add to that pool. I need to be able to dynamically change members of that pool. And the devices I'm talking about, they shouldn't necessarily be servers. They should be anything. Maybe it's a server, but maybe it's a public cloud resource like an Amazon instance. Or maybe it's a handset. Maybe it's actually a device that I'm physically running things on. Or maybe it's a bunch of VMs. And Commander is agnostic on both fronts. Lets you pick any device as the end target, and lets you define resources so flexibly that you can tag them any way you like. And then when it comes time to running things in parallel, here's a classic example of a trick that only Commander can pull. Windows, Linux, and Solaris Unix system and tests all running in parallel on completely different hosts that were discovered at runtime. What did it take to set that up? A checkbox. To set that up in Commander, all I had to do was say, yep, at this level, these different parts of the process are safe to run in parallel. Give it the click the checkbox for parallelism, and you'll get parallelism at a heterogeneous level and results in real time as these things are churning away in parallel, potentially on completely different geographies. Commander is watching the outputs of these and centralizing the results. So that's how do you make things fast. What about making things secure? And again, the idea behind secure is to make things shareable. Unfortunately, I think a lot of products which have started to implement security for continuous integration systems or build management systems or software process systems, ALM systems, they've modeled themselves after other enterprise products where there's this notion of a role. The idea is that, well, I'm root, I'm a developer, and you're an author. So I get everything, and you get nothing. And the problem is that's not how software development teams organize. Every team I've ever been on, all the guys on the team, all the developers on any given team, they all have access to all of the machines that participate on that product. We all had root access, or we all had enough privileges to install or reconfigure or update tools, whatever it is we needed to do our jobs, all the efficient teams I've been on. But that doesn't mean that I have root access to every system in the company, and I certainly don't even have access to the ones that my next door neighbor's working on, other ones where I am just a reviewer or a contributor. In other words, if you're going to do this right, access control needs to be on the object. And it needs to be fine-grained. And we shouldn't have to make assumptions about what roles people have because people have different roles in a modern organization. And I want to be able to, if I'm going to have that, I need all the associated technology of being able to have permissions inherit and tie them to LDAP groups and be able to break inheritance where I need to. And that's a lot of work to put into a software build and production system. But we signed up for that task with Commander because we know without it, you're not going to actually be able to give your developers an infrastructure that they'll use. And you can kiss your cloud vision goodbye at that point, because if dev doesn't get the tools and the processes and the authority they need, they're not going to use it. They're going to. That's when you guys got guys running off to Fry's, buying cheapo systems, plugging them under the desk, setting up their own Wi-Fi routers because they don't want to play by IT's rules. When if they play by IT's rules, they'll get so much better support. How do you solve this conundrum? You get a system which gives you fine-grained object-based control and give the developers exactly the permissions they need. How do we make things usable? It means a UI that is so flexible that it looks exactly like what you need. Here's a screenshot of Electric Commander that was slightly customized. That launch tab doesn't come out of the box, but when we, just with a little bit of work, this was no more than an afternoon's work to get this screen up, this shows up now front and center in my product, indistinguishable right alongside all the other product tabs. And here, this was for an organization that needed to be able to launch firmware builds against different models of their handsets that they were targeting, and then also they had to customize it by carrier. And they wanted a nice UI that was even intended to be used by developers. It was the knowledge experts. It was the guys, basically a division of product management, who knew that they needed to build out candidate builds for different kinds of configurations. And that's the kind of thing you can build in Commander. Why? Because my system is wide open. We have an SDK that lets you customize not just the data level, not just the process level, but even the UI level. And we did let you use whatever UI technology you like. This one happened to just be a simple Perl JavaScript kind of CGI, but we also support full-blown GWT to let you customize and give exactly the UI, exactly the highly interactive UI that your customers need. And Commander is so well suited to this because at the end of the day, all the data you'd ever want to present is there in Commander properties. And all the activities you ever want to launch in response to collecting data is all in Commander procedures. It's a pleasant task to define the UI for that because all the hard parts are already there, and you can give your users an interface that looks exactly like what they're used to doing. And yet, it is going to be connected to back-end private cloud resources, right? So you give them this interface, and it's their on-ramp to a cloud, and that's how you maximize utilization. Finally, I talked about managing the metadata, someplace where we're going to capture the inputs and give actionable reporting. And I love to just phrase the problem this way. When I often talk to customers and they're starting to explore how their system works and what we can provide, how we can help them make things better, I often ask, so do you have an automated build or an automated test system that sends out emails when things go wrong? And almost always in 2011, people will say, of course, absolutely we do. And I said, does it give a little thing? I bet it's got a timestamp down to the seconds, and it'll tell you that it failed. And yes, absolutely. So it looks something like this, yes. But here's my question to the audience. If you sent something like this, and I'm not even going to tell you what industry or what job 17 was supposed to do. Let's just say it was a software build of some kind. What would be the next question you're going to ask? And I bet if we took an audience poll, 80% of us would agree on the next 5 questions to ask. Has this failed before? What was different about this build? Where did we run it? What source changes went into this one? Is it the same? Are we running tests or are we running build? There's always the next set of questions that comes out. And the challenge I have to organizations is, if we're all agreed on what the next 5 questions are, why can't we show the answers to those questions too? Why can't we up-level all the information that Commander, that the process is generating or providing? And that's exactly what Electric Commander does. This is what we call the report card report, and it comes out of Commander by default. And this is very simple, just shows you against platforms, against steps, are things green or red. So at least you can orient yourself. In this particular build, was it just Mac that failed, or was this failing across platforms? But as soon as I answer that question, I'm going to want to dive into it. Like, okay, tell me what exactly failed. And that's one of the cool things about Electric Commander is that because it is watching every single output, because it is literally looking at standard output and looking for patterns, when it sees the word failed, it bumps up a counter, and it takes a little excerpt, and it puts it right in front of you on the diagnostics tab. So one click away from you is exactly what failed, exactly what output is there, and Commander comes with built-in patterns to recognize pretty much every build tool you can imagine, every compiler that's out there, and it's so easy to extend it to recognize what you are teaching your system to run, that we give the ability for people to have one click away. This now becomes a URL that you can bookmark, you can paste into an IM or send to somebody and say, dude, check this out. What's going on? This is busted. I think it's you. Can you please fix it? But how about the other question? What about if we zoom out? If this is failing, don't I want to know how long has this been failing? Is this failing just today? Has this been green all along? I can draw reports that show me trends because all of this is being captured in one place. And once it's captured, you can ask questions like, when does this fail? Holy cow, this thing fails the first Tuesday of every month. Oh my God, that's Patch Tuesday for Microsoft Update. Someone turn off that. That's exactly what's happening. You can't see those trends unless somebody can show you that kind of picture. In short, what you want is multi-level reporting. You want to be able to show what's happening all the way down to the individual test, to the individual command, and yet trend up, all the way up to a report that you could throw onto the boardroom table and say, here's where we are, here's how things are going, we're on time, we're not on time, we need more resources, we need more time, I can prove it to you because here's the data. When you have that, when you have something, if you're going to get everyone into the cloud and you're going to get them using one system, it's so critical to have that actionable reporting, not just megs and megs of files that everyone's expected to grep through, but something which can pull out what's relevant and show the picture that people will actually care about, that they can act on to be efficient. So I just wanted to give an example of a customer. This is a large database company. You all know them. I won't say their name. And one of the challenges this group had, with this particular division of this company, was that they were trying to automate automate their tests. They had continuous integration, but they didn't have continuous tests. The test took a long time to set up because it was hard to provision the box. They needed to run it against multiple operating systems, and there was this queue, and IT was involved. Developers now had zero access into this. QA could run it, but it was very tedious and very error-prone to run it. There was never any visibility, team-wise, into the state of the release. What were they able to implement with Commander? It wasn't just fully automated continuous integration, but it was fully automated continuous test and regressions. They literally were able to set up a kiosk service. The cloud had an easy-to-use front end that any developer could go to and say, hey, run a test for me. Even cooler, run a test with my, get this, unchecked in sources. You were able to upload a little patch and say, here's something I'm thinking of committing to main branch. DevCloud, could you please run this for me and let me know, am I about to break everything or is this good? And that was transformative in the developer's ability to have confidence, to move at high speed, to get that productivity cycle that we were talking about as fast as possible. And yet, because the whole team knows the state of the product, filing a bug, which used to be such a tedious process, simply became pasting the Commander job ID, because the Commander job that ran the system test, that ran the regression test, had all the inputs. It knows what system things ran on. It reserved those resources, blocked them off when there was a failure. It was able to tie into their workflow and show you all the inputs that somebody would need to reproduce a problem. So just to summarize, the cloud values are real. The accessibility, the scale, the self-service, the elastic assignment, those are all something that we are for sure going to see as a fundamental part of just computing in general going forward as we enter this next decade. And it's clear to me that while public cloud has a lot of application, especially for consumers, when we're talking about an enterprise-level transformation, the spies and straws problem is too real to ignore, and private cloud is going to come first. And who is going to gain the most in the private cloud? It's the people on this call. It's the developers and all the associated teams, QA, release, product management, anybody who is trying to get software out the door and is trying to map that complex process to the complex resources needed to it. That is what the vision of the private dev cloud is. But if we're going to solve it, if we're going to have an impedance mismatch adapter that sits in between IT's infrastructure and dev processes, it's got to be able to understand development. It's got to be fast, secure but shareable, usable, and be able to manage all the metadata. And that's exactly what Electric Cloud does. Okay, I just want to give a couple more slides about us and our products. Again, very briefly, I mentioned that the Electric Cloud solution consists of Commander, Accelerator, and inside Accelerator makes the build fast by distributing it to a cluster of machines, and Commander manages the entire software development process and can map to your private dev cloud. We're very proud of our customer list. We're working with leaders across multiple different verticals. Some of the biggest, most complicated software builds in the world are managed and accelerated by Electric Cloud software, and we're very proud to say that we have virtually no shelfware. Our products get used and get immediately installed as central to these organizations. You can recognize a lot of the names and the logos there. And it's really the only solution out there which can solve the entire software production problem. And at the end of the day, that means reducing the cost, making the efficiency of your organization better, again, optimizing both that dev cycle and that IT cycle. And what does that mean? That means higher software quality, faster, and of course, direct cost savings to you. More information, of course, please don't hesitate to visit our website, electriccloud.com, or give us a call, or we'd love to hear from you just even about this webinar. If you have comments or questions about that, just send a note to info@electriccloud.com, and I'm happy to take any questions at this point. Thank you.
Thanks, Usman. Great presentation. There were a few good questions, actually, and anyone, if you have additional questions, go ahead and use the chat box down at the bottom of the screen here. Well, the first question was, how is a private cloud any different from having a bunch of virtual machines?
That's a great question. That's a great question. And I think a bunch of virtual machines is definitely starting to look more like a private cloud than it would be if you just had a bunch of servers, in the sense that you've got the virtualization. But what you don't have is elastic assignment, right? So virtualization is key to support that heterogeneous environment where a big iron box can now change. It's got that chameleon effect. Now I can become Linux. Now I'm Windows. Now I'm x86. Solaris x86 or what have you, turning into the resources that somebody needs. But that's not the same as saying that I want to be able to click one build and have my entire system process go, system test go, or I want to be able to run a test and have it automatically pick which resources it means. It means a layer above virtualization, something that can work directly with the virtualization tools, whether that's, for instance, raw ESX or Lab Manager. Talk to that level, instantiate resources on the fly, and then tie that back to what people actually do. That's how we define private dev cloud. And until you start to see that, you won't see the transformative benefits. So I think that virtualization makes private clouds way more interesting. I think it's a very powerful but not necessary agreement. You can still have a private cloud without virtualization, but it's only when you tie workflow to that resource mapping that it becomes what we believe is the power of private dev cloud.
Great, great. Hey, I just want to post a comment that was also mentioned too. It said, excellent presentation. It goes way beyond what they've been fighting in their organization. They've
great to hear.
But,
excellent.
But they don't want to hear about change. So another.
I can comment on that too if we have a little time on you. Okay, if you like what you're hearing, but man, no one in my organization's ever going to go for it, man. Those guys, they've got their way of doing things, and they're never going to listen to. Just my short answer to that is, one thing is show them this, to let them know this is what the best and brightest organizations are doing. Your competitors are doing this, but I would say it's show concrete results, right? So look, this is going to make the build go faster. Start small. What tangible benefits are going? Let's take a page out of the Agile book. Why did Agile get adoption, right? Because it's that idea of, look, there's a whole big book here, that's 100 pages long on process, but what is the one thing I'm going to get out of this? I'm going to get a faster build. Boss, you're going to get a report that can show you where machines are going to be used. IT, that rack of systems, everyone's going to be able to use that, but you'll still have root access. Just bring in the one value, and that one value will help ease adoption. That's what I've seen.
Great. So another question just came in. A few, actually. So one person said, I like the idea of a private cloud, but how do I justify costs?
How do you justify the cost? Right. So the way to justify the cost is to look at the impact on cycle times. If you want to do the sort of the hard ROI analysis, what our customers do is they start to look at, well, where are people wasting time? And they're wasting time on running builds, and they're wasting time on getting test infrastructure set up, and they're wasting time on figuring out where things went wrong. And it's not hard to sort of just take a couple of rough estimates. And I've got customers who went way overboard on this. They instrumented make, and they were watching to see how many invocations were, and they multiplied that out. But even a back-of-the-envelope calculation will start to show, wow, we are wasting an enormous amount of time. We are paying your developers for their brains, not for their typing and clicking and remembering of passwords ability, right? So as soon as you start to multiply that out, I think the ROI is there. The other angle is, look at the machines and the infrastructure you have as a sunk cost. That's there. Right? So how do we get the most out of that? We would never walk into Electric Cloud and say, okay, start over. Part of our vision is the private cloud, the raw materials for that private cloud are there. What you're missing is the software to manage it and make it fast and efficient and easy to use. And so if you look at it that way, look, guys, we've invested in this. We're not getting the value out of it. What is missing? What's the gap? And that's really the thrust of this presentation is, and look at it, what is that gap costing you? Then the ROI analysis can be a lot smoother.
Cool. Here, let's address a particular question that just came in. Looks like our old friend Matthew Johnson. And, well, they say they have 50 so developers, and our existing cycle is sync source to local workstation, build the source, install the binaries to local workstation. Can Preflight be tied to the allocation of additional resources to support the installation of the product immediately after the build? This would be the closest thing to their closest analog to their current process.
Yeah, so this is Preflight refers to the feature of Electric Commander that lets you, we have tight integration with source control. So imagine this, right? You're hacking along, you've checked out files, you've just modified foo.c, and you are about to put changes back into mainline or back into your integration branch. And then from there on, it's sort of you throw it over the wall and cross fingers and pray that you didn't break things because you're beyond the hook for fixing it if it did. The idea behind Preflight is Electric Commander is talking to our source control server, to your source control server, knows what changes you've made, knows that you modified foo.c, knows that you removed bar.h, and can batch that up and send it to the Commander server, and so that Commander server can effectively do a trial, build, and test with unchecked-in sources. That's what we call Preflight. It's a really slick feature, and it's transformative. The question is, can Preflight be tied to the allocation of additional resources to support the installation of the product immediately after the build? Sure. Absolutely. Preflight is actually a framework that comes with a bunch of scripts that are useful out of the box, but the underlying technology there is eminently hackable. As I was a product manager at the time, and we insisted that dev make this thing and put hook points in everywhere. So you can absolutely push up a full build if you want, and push that to exactly the resources you think are important. That process is infinitely flexible, and you have all the hook points you need to do that. So the answer to the question is absolutely, and yes to other permutations on that.
Great. A few people are asking where they can get a copy of the slides today, and I just wanted to mention over on the right side of the screen there's a tab that says Resources, doesn't actually say Slides. If you go there, you can find links to download a copy of the presentation as well as links to Electric Cloud and other things there as well too. Okay, another question for you, Usman. What OSs are supported? Slides talked about Win32, Linux, Solaris. What about OS X, Android, etc.?
Okay, so Electric Accelerator runs on Windows, Linux, and Solaris, and almost all the flavors 32 and 64 in there, and different architectures on Solaris, x86, and Spark. Electric Commander runs on pretty much anything under the sun. The server runs on Windows and Linux, but the agents, which is where the work does, supports Windows, Linux, Solaris, AIX, HPUX, Mac OS X, Windows and Linux and various flavors of that. And we also have an adapter called the Universal Agent, which can talk to basically anything that you can open a network protocol to. Anything with an SSH connection is fair game for starters. And so, yeah, and we've got customers who are using that, for instance, to drive tests directly on an Android handset device. So there's a lot of flexibility to support different platforms here, and if I glossed over them, it's because I've got customers who use so many different of them that I probably can't enumerate them all myself.
Gotcha. All righty. So let's see, another question. Is there any particular company size where this idea wouldn't really make any sense? Oh,
that's a great question. I don't think so. I think this is useful for going all the way down to a couple guys. And the proof of that is that we've had customers who have used our products and then have gone off and started things in smaller companies, and immediately they say, oh man, it's a bummer. I'm missing Electric Commander, because that's how they think of a software production process. Once you start thinking of it as, yeah, this stuff belongs in a central service. It doesn't belong on my local workstation. That's where I do my bit of it. But once I've got my bit done, I should push a button, and that should go into a central place that everyone can see. Even if everyone is just me and my buddy Joe next to me, that vision of it's in a central place that's shared, that we know that's where we scale things, that's where the official builds are done. I think that has value even in the smallest teams. Certainly the value multiplies tremendously as you get big and as you add more products, more lines, more anything. Certainly Electric Commander is most valuable to the organizations with complexity. But I think conceptually, no, there's no organization, no size too small. I think that it's applicable to even small groups, and we've actually recognized that in our business by making Electric Commander available at a workgroup edition, which you can find more information about at our website, which is scaled for smaller teams.
Great presentation. I think we're just about out of time as well, too. I'd like to thank you again, Usman, for joining us today. It's
my pleasure.
Great overview. All righty. And thanks everyone who joined us remotely. We had people visiting from around the globe as well, from their iPods and iPads today. And I'd like to thank everyone who helped put the presentation on. I look forward to seeing you on our next CM Crossroads livecast presentation. Bye-bye, everyone.